Welcome to week 8. Now we are doing the trolley assembly, and I am not providing step-by-step videos for this one. You'll fly solo on several of these parts. I do want to touch on some of the high points to kind of clue you in on some things, and you need to take into consideration the tolerancing on part number 3 and part number 2 and part number 5, because all 3 of those parts have holes that have to be concentric for these bolts to go through. So take into consideration what your basic dimension is going to be from center of hole to center of hole when you start making those parts. Okay. This thing, oh, I had to unplug my 3D mouse. I'm reaching over here, turning it, and it's not working. You'll notice parts number 8 and 9 are snap rings, and these hold the ball bearings and the wheel onto the axle. So if I hide this wheel, okay, oops, wrong move. Okay, because I've got those as a sub-assembly, I suppose. Yeah. Okay, so let me back up a minute. Let's look at the ball bearings. Now, I give you in the DWF file that I provided for you to download, I gave you minute dimensions on this. So you basically create the inner ring as a part and the outer ring as a part. And those are best done by revolving. Nothing new there. Create a ball, which is a sphere that's just revolved. Or I think there's a primitive that you can use to create spheres with. And then if you will align and constrain the outer ring and the inner ring together with flush edges and concentric axes, they'll be done correctly. And then you place one ball bearing inside there, tangent to the groove. I'm reading Blackboard. Constrain the ball bearing tangent to both rings. And you may need to apply a an angular constraint to lock it in place, and then just do a pattern to copy that thing around so that you've got 8 of them. Okay. And so in real life it would move, but in our model we do not want it to move. And then save that as a sub-assembly. Okay. And then when you come to your assembly here, you could bring it in with all these other things, or you can create, as I have done here, I've created another sub-assembly that is the axle, the ball bearing assembly, the wheel, and the 3 snap rings. And I'll hide the wheel, and you can see there's 2 of the large snap rings on either side of the ball bearing, and then a smaller one that holds the ball bearing onto the axle. And the trolley wheel, you notice that there are grooves inside the center of the wheel that these snap rings fit into. Okay. And I would recommend that you go ahead and constrain those things in place and give them an angular constraint, or do a rigid, joint, however you feel. I'm kind of leaving that up to you as to how you assemble this thing. But I did them as sub-assemblies. That way I have fewer parts to work with at a time. Now it complicates our parts list, but we'll deal with that when we get to that point. Okay. All right. The other thing on this one is right here. The book has 1 dimension of bolt, an 8 3/4, but an 8.5 is what is available in the Content Center. So use the 8.5 long one. Assemble it and constrain it. Put the castle nut on and constrain it so that, as you can see, I've got them facing, with a flat facing up. That's fine. You can do a flat facing up, or you can do a flat facing out horizontal. But get them in place, and then you will, let me flip over here. You want to create a hole through the end of the bolt right there, and this is going to be done in the assembly. Or it'd probably be best to have everything constrained and then edit this in place. Where's that? Edit it in place to put your hole. And then when you come back to the assembly, it's there in the correct place, and your Cotter pin will slide right into it. Now, the Cotter pin, if you look in the appendix, and it is page A72, there is the chart size for the dimensions on Cotter pins based on the size of the pin and the size of the hole. Okay. I also give you dimensions on how to draw this on the DWF file. And what I did is I created a sketch here of the outside path of the Cotter pin. And it's kind of difficult to see on the DWF file, but the spacing between these two is 0.002, I believe is what I had. Let me look at the DWF file. Yeah, 0.002 is the spacing between these two profiles. All right, and sketch number 2 is a cross section of the Cotter pin. Okay, and it has a radius. I've got that turned off right now, and then a line up. Actually, I don't have it. What do you know? That's bizarre. It's amazing what you find when you go back and look at things from long ago. Aha. There. Okay. So I just do a cross section of it and then do a sweep, and that creates my Cotter pin, which goes in the hole with the castle nut, and constrain that so it's in place. It's not wobbling, it's not turning, it's not sliding in and out. Okay. It should be fully constrained. Now you need to pay attention to your constraints and how these things go together. Honestly, I think it's pretty self-explanatory on some of these things. The little keeper plate holds the axle in place. 2 little screws hold that. They've got holes, threaded holes beneath them. You just need to compare tolerances and hole locations from one part to another part so that you're getting things in the right place to start with, okay? And when you go to document your drawings, pay real close attention to the notes, like material types. A couple of these things are, the material type is HRS, that's hot roll steel, okay? Part number 5 has a note that says tumble to remove burrs. That needs to go on your drawing. Looking at some of the other things, lots of tolerances on the wheel. And the snap rings, create your own snap rings, because the grooves in the parts are based on this size of snap rings. It would be rather complicated to go through the content center to find a snap ring of the correct size that we want to use. So go ahead and use this create your own snap rings. And let me look at my notes here. The ball bearing parts can go on one drawing, okay? Just like in the DWIF file would be fine. Both snap rings can go on one drawing. That'll be fine. Okay. And I give you notes in Blackboard on part number 1 should have a full section. And let's see, what is it? Part number 4, which is the axle, should be in half section. Wait a minute, I'm backwards. No, part number 4 should be a full section. Yes. Okay. Not broken out sections as shown in the book there, but go ahead and create those with full sections. Dimension things, tolerance things, watch for your precision, your decimal precision. I'm looking right now to see if there are any finish marks. I'm not picking up on any. That's not to say that there. The axle part number 4 has a note that says grind. Okay, so that will go in as a finish mark with the letter G. Okay, and then I'm also providing you with a really good example of the exploded isometric drawing that Kristen put together when he took this class. Okay, now his part number thingies are a little different. We were naming things differently back then, so you should be saving the files as 14-53-1-2-3 like that. And in the description would be the name, keeper plate, side plate, adjusting shim, so on and forth like that. And then it's just a really good example of exploded isometric drawing for this assembly. Although I'm not real sure what happened with this one Cotter pen, because it looks like he drug it out at an angle instead of bringing it straight out. So that's an example for you. Give it your best shot. And if you should decide to do sub-assemblies and you have trouble with your parts list, let me know and I will get in touch with you on how to correct that.